In this video, I want to look at how you can convert mole fractions to mass fractions and vice versa. Whenever you have one of these problems, it is most common that they simply give you the percentage of each component. And in that case, if you want to switch over to the other type of percent, you need to assume a basis for calculations. Now, if you have mole fractions given, then I would basically assume so many moles of substance, or kilomoles or pound moles. It really doesn't matter. And 100 is a convenient value because then percents just simply tell me how many moles of each thing I have. Another thing that you need to keep in mind as you're working these problems is that the sum of my mass fractions or the sum of my mole fractions, as I add up for all the components, must add up to 1 or 100%. And sometimes this is a way that I can fairly quickly check and make sure I didn't mess up any of my calculations. So let's look at an example. So I have a gas, it's 10% carbon dioxide, 30% water, 40% oxygen, and 20% nitrogen by mole. And I want the mass composition. So I find it easiest to solve these problems by creating a table. It helps me organize my work. So what I usually do is I list my components, and then I add a little row down at the bottom for my total. I was given mole fractions, so I'm going to put number of moles, and I'm going to need the molecular mass. So this will be data that I'll look up. I'll be computing the mass of each of these components for my basis of, in this case I chose 100 moles, and I'll be computing the mole fraction, or mass fraction, excuse me, exabyte. So if I have 100 moles, it's 10% CO2, then that means it's 10 moles of CO2. And similarly for each of my substances. If I add these up, I get 100. Now this column is just data, so there's no point in adding this one up or doing anything with that. This is just data. To get to mass, this is, say, grams per mole. I have moles, so I'll multiply to get the mass. So 440 grams of CO2, 541 grams of water, 1280 grams of oxygen, 561 grams of nitrogen. If I add these up, it tells me how many grams I have of the total, 2,821. To get to a mass fraction, I'll take the mass of any given substance divided by the total mass. So 440 divided by 2821 is 0.156. 540.6 divided by 2821.1 is 0.192, and so forth. I can verify by adding these up. I get 1, and so I have my mass fractions here. Now, if you add these up and you came up with 1.001, or whatever your last digit is, if you're off by 1, 0.999, 1.001, either of those, I would consider it to be close enough to adding up to 1, and the problem would just simply be with round off. Okay? So don't get too worked up about it unless the error is over in one of these other digits. But as long as it's in my last place I was tracing, I consider that to be close enough. Now, this is my mass composition for my substance, and it's different than my mole composition. What about the molecular mass of the substance? I have the number of moles and I have the mass for this sample, and so I could simply take the 100 moles, the 2821 grams, and come up with 28.21 grams per mole as an average molecular mass. And if you go back and look at your data, you see that yes, indeed, 28.21 is somewhere in the middle of all of these, which just simply is logical. Now, what if I wanted to go from mass to mole? Essentially, I do the same sort of thing, but I'm going to start by assuming so many kilograms or pound mass or grams, whatever sort of units you wish to use. Again, I think that using 100 is convenient. So I have something where now I have oxygen, nitrogen, and methane, fractions given by mass, and I want to know the molar composition. So I list my components and my total. I've chosen a basis of 100 kilograms, so I have 50 kilograms of oxygen, 20 of nitrogen, and 30 of methane. I look up the molecular mass of each one of these. Now I compute the number of moles. Before I multiplied, but now that I have kilograms, and I want kilomoles, so I'm going to divide by the molecular mass. Again, remembering that the units are kilograms per kilomole. In order for the units to cancel, I'm going to need to divide. And so I have the number of moles of each substance. And again, I can add these up. This is 4 moles, okay, where it used to be 100 grams or kilograms. Take the number of moles divided by the total, and I get the mole fraction of each of these. Again, verify that they add up to 1, plus or minus the last significant figure.